Okay, this video is about how to find the final temperature when you're doing a calorimetry type of problem. So the first thing that you'll need to know about calorimetry, like the whole basis of it, is this right here. That when you have so we're having some water and some metal. So if you take the Q of water, so the energy that the water either gains or loses, that's going to have to be equal to the Q of the metal. Now, if you read this problem, and if you look, the metal is, okay, is at a temperature of 18, and the water is at a temperature of 85. So the water is hotter than the metal, so the water is going to lose energy. So this is a critical part right here, is that you got to figure out which one of these is going to be losing the energy, and so the water is going to be transferring its energy to the metal because the water is colder. So you have to put a negative sign in front of that. Then you can rewrite what Q is equal to. Remember that Q is equal to MC delta T. And so I'm just going to write that out here for each one. So I'm just going to write that Q for the water is going to equal MC TF minus TI. Instead of doing delta T, I'm going to put in the actual TF minus TI. And I'm going to put a negative in front of that in brackets. That's going to be equal to the Q of the metal, which is also MC TF minus TI. Now it's a positive because energy is going into that. Okay, then you read the problems and you just plug in the numbers. So a piece of metal with a mass of 45. Okay, that's the mass of the metal. Now I'm just going to leave the units off because it gets kind of messy. Okay, and a temperature of 18. Let's look for this. Let's find the specific key to the metal so I can do it in order. So the specific key to the metal is 0.38. Okay, we don't know the final temperature because that's what we're looking for. What's the initial temperature of the metal? 18. Okay, that's going to be equal to the water. So we're going to have a negative sign with bracket here. So the mass of the water is 100 grams. The specific heat of water is 4.18. Oops, don't want that. Get rid of that thing, however I need to do that. Okay, let's go back to this, all right. Times TF, which we don't know, minus TI. What's the initial temperature of the water? It's at 85 degrees Celsius. Okay, I'm just going to leave the units off to help out a little bit. Okay, now let's kind of condense this. So 100 times 4.18 is going to be equal to 418 times TF minus 85. And then I'm going to put that in brackets still with the negative sign on it. And that's going to equal to 45 times 0.38. So 45 times 0.38. That's going to equal 17.1. So I'm going to write 17.1 times TF minus 18. Okay, then I'm going to distribute. So 418 times TF, so it's going to be a negative still here, but it's going to be 418 TF. So I'm multiplying 418 times TF minus, what's 418 times 85? That's going to equal 35530. Okay, I'm going to leave that in brackets. That's going to equal 17.1 TF. I'm distributing the 17.1. And if I take 17.1 times 18, that's going to equal, oops, not equal, I don't want that. I need to have a plus or a minus sign there. So let me erase that. So I need a minus sign here. So 17.1 times 18 is 307.8. Okay, now I'm going to distribute the negative across. So the negative makes the 418 TF negative, but it's going to make the 35530 positive. That's going to equal 17.1 TF minus 307.8. Now I'm going to combine like terms. Basically what I'm going to do is I'm going to move the 307, it's negative, I'm going to move it over to this side, and so it becomes positive. So I'm going to have to add 307.8, and I'm going to move the 418, which is negative on this side, over to this side. So if I take 307.8 plus 35530, I get this. So basically, I'm adding 307.8 to both sides, 307.8, and then I'm going to basically add 418 to this side and 418 to this side. And what I end up getting then is I get 35837.8 is equal to, let's see, I got to do the math on my calculator, 418 plus 17.1. That's going to equal 435.1 TF. Now I need to get TF by itself, so I'm going to divide both sides by 435.1. So I'm going to take 35837.8 divided by 435.1, and that's going to equal 82.3. So my final temperature is equal to 82, I guess if I rounded it off, 82.4, if I'm a little more precise there. All right. Okay, so that's the final answer. Now, when you get done, there's a lot of algebra, and it's easy to make a mistake, but you want to go up and you want to find the temperature. So the hot thing was the water is 85, and the cool thing is the metal, 18. Is your answer somewhere in between those two numbers? And if it's not, that means you did something wrong. 82.4 is in between. It's pretty close to 85. But now let's think about why that's the case. It's because water has a specific heat of 4.18 joules per gram degree Celsius, whereas this metal has a specific heat of 0.38 joules per gram degree Celsius. So what that means is the metal's temperature is going to change way more than the water, which you can see that it did. And so our final answer should be closer to 85 because that water has a way higher specific heat. So I'm pretty confident that I did that problem right. All right, that's it. Good luck.